Welcome to another teardown video. This time it's a digital multimeter from Black Star called 3225 MP, and the MP version that is including mains supply. If there is no MP, that means it's with batteries. And this is a little bit confusing. 2 amp fuse here, and then the meter goes to 10 amps. So maybe there's a fuse for the 2 amps and then 10 amps is here. So maybe the fuse is inside. I have no clue, because this instrument is quite old and I'm not able to find a manual. It was sold by Farnell. So it can't be more than, what, 20 years? Also, we see the CE marking. So that means it can maximum be 23 years old or something. So that is the maximum. And it's 230 volts as well. This also reveals it should be quite new. And as always, I promise to take a video when I power up stuff. Nothing. 1.3 watts of usage, and the unit is off. So that means this is not the main breaker. So okay, no kaboom, and still 1.3 amps. Oh, that is funny. Really? Why do you have an on-off switch if... Haha, you gotta see this. Really? Okay. Look at the display. Look at the... Come on, man. Here we go. Off and on. This thing is 1.3 watts. No matter if it's on or off. So that means, why the heck would you turn it off? Why would you have an on-off switch in the front? There is no additional on-off switches in the back, so this thing is always on. Oh, funny. Alright, so it's on, and we go volts, 200 micro, 200 milli. Okay, let's go for 200 milli. That is easy to make, right? Just plug in some volts. So let's just do let's do 100, and just to be a little bit what? I didn't expect that to happen. Okay, so this is the volt, 200. Okay, now I understand. Volt. So this is 200 volt full scale, 200 millivolt full scale. Oh, okay, I was stupid. So if this is 200 millivolts full scale, then 99.2 is very close to the 100 millivolts I set this up to deliver. But do we really believe this to be true? Let's put on. Let's connect this. So what have we got? Okay. So we got 99 millivolts. This is just typical. It's always a little bit. So this is what we really got. 99.1 something. And this one is 99.4. All right. This is really close. So let's crank it up to 200. Oops. Sorry about that. I mean, let's go 190. So what is it in reality? 189.59. Okay, that is okay. This is actually pretty good. This is not bad at all for a 3.5 digit meter, and it's probably what, 15, 20 some years old. So that was the 200 millivolt, 20 volts range, and it is of course 190 as we got. So in that range it's also good. So how about we crank it up a little bit more? So that is 1. Yeah, correct. Let's go all the way to 10. Okay. That is really not bad. So this is 50 millivolts. It's reading too much. And this is what we got. So it should have been... I bet there will be some trimmers in here, so we could make it read absolutely correct. I can't wait to open this and see if we got some trimmers. I think it's about time to open this thing. And it's just 4 screws, right? Yep. Let's remove the mains, find a screwdriver and get in. So we are... Oops, it sounds a little bit like this is the bottom. I think we should maybe... Yes, that is definitely what we should do. Oh, look at that. Wow, that is really nice. Look at that. I really like that. Typical. There's somebody at the door. I gotta go. Here is the power supply board. LM78L82. So this is actually 8 volt. And this is the rectifier. Just those 2 diodes. And they have a center point for the transformator. So this is why they only need 2 diodes. And we got 12 volts on the capacitor and then 8 volts out of the regulator. And this is how the PCB is carefully assembled between 2 pieces of metal. Really nicely done, and everything here is shielded because of course it is a plastic case. So this is a great way to shield everything, to close it. Let's try and open it a little bit more. I don't know how easy it is to see this white resistor down there. This is the 10 amp current range. This white resistor down there. And there's no fuse in the 10 amp range. This is just how they made the 10 amp range. Pretty cool. Look at how they trim the different ranges by soldering resistors on top of other resistors. Got a trimmer and a trimmer for something. Got some op amps. Analog multiplexer for selecting different things here. We got some really nice 0.1% resistors. And what have we got here? Capacitors of some sort. And trimmer capacitors. That is interesting. So what are they doing that for? Is this for compensation of the voltage dividers for AC? Because remember, this thing can also measure AC RMS. So this is what you need to do to compensate the voltage dividers. So this is from 1986. I love it when I see information about that. And again, 1986 on the display board. This black star again, and this is just the classic LCD voltmeter analog input chip. Yeah, I think that is all I wanted to show about this cute bench voltmeter. And of course, why would you pick this one where you could use one that was a lot closer? Yeah. And this is again, all metal parts are connected together. This is a really, really good idea for hum and ESD and such. So you get a really nice and stable readout. Yeah, I believe this one is the reference because they only use 2 pins. Probably a reference diode. And if I'm not guessing wrong, it would be 2.5 volts, but let's try and measure this. Ah, 1.216. I guessed wrong. How can I be so bad?